this is for Year 11 methods. We're going to look at exercise 5C, question 13. And this is to do with the functions exercise. Okay, so we're learning function notation, and we're also learning how to draw graphs in function notation. Okay, so the first graph is f, the name of the function is f, such that the domain is -1 to 2. So the x values the function can take is from -1 to 2 inclusive. And the rule of the function is f of x equals x squared. Okay, let's draw this function, because I know that this graph is essentially a normal quadratic. Okay, the only difference is I've got a restricted domain, meaning that I'm not drawing the full graph. I'm drawing the graph from -1 to 2. So first things first, because I know what the normal quadratic looks like, but we only want a part of it. We only want the piece between -1 to 2. So first things first, we need to actually find the endpoint. So you'd simply sub in x is -1 into the function. So you're replacing -1 with x. You're replacing the x with -1. So you go -1 squared equals 1. And you're finding the endpoint of the other part. So f of 2 equals 2 squared, which equals 4. Okay, so the endpoints are -1, 1, and 2, 4. So let's actually draw this. We know that this goes to 2, 4, 2, 4, and this only goes to -1, 1. Okay, so -1, 1, -1, 1. Now, I know I ping students for not drawing the graph proportionally. If you don't do a scale, that's fine, but make sure it's roughly proportional to each other. Okay, so it doesn't need to be exact, but make sure it's roughly proportional so that it actually makes sense, like what your coordinates are. Okay, so what my range is what y values the graph can take. Okay, so if we look carefully, the y values go from 4 to 0. Okay, so that's my range. So it's going from 4 to 0, or 0 to 4. So my range is from here to here. That's the y values it can take. So my range is given by 0 including to 4. So you go from lowest to highest, 0 to 4, and they're both inclusive. Now, the classic mistake people make is they look at the endpoint and go, okay, the endpoint starts at 1 and it stops at 4, and my range is 1 to 4. That's not correct. So you've got to be really careful to get the right range. Okay, so the range is 0 to 4 in this graph. All right, we'll have a go at B as well. We've got another quadratic graph, x squared plus 2x, and the domain of that graph is -2 to 2. So what that means is we don't have that full graph, we only have the graph between -2 to 2. Again, we have to find the endpoints. So first things first, if I got f of x equals x squared plus 2x, if I want to find the x-intercepts, I let f of x equal 0. So I'm going to let that equal 0. So it's similar to how you treat a normal y equals x squared plus 2x. Okay, factorize it, because I want to find, I want to use null factor law to find the actual intercepts. I know my x-intercepts are at 0 and -2. Okay. For my turning point, I know that the average of the two values is my x turning point, so it's -1. My y turning point, or to find the y turning point, I'll go f of -1. So I'll go 1 squared, -1 squared is 1. 2 times -1 is -2, so we get -1. So turning points at -1, -1. Y-intercepts is just when x equals 0, y equals 0, or f of x equals 0. So the y-intercept's at 0, 0, which makes sense. So when I draw the graph, we have an intercept at 0 and at -2. Can you see our domain of the graph is going from -2 to 2? I know the graph shape is going to look something like this because it's upright parabola, and we got a turning point at -1. My endpoint is actually at -2. It's actually at the x-intercept because it terminates there. It says we stop at -2, but we do go on to, we do go on to 2. So let's have a look at, just readjust the screen. Let's have a look at where the endpoint is for when x equals 2. So f of 2 equals to 2 squared, 4, plus 2 times 2 plus 4, which is 8. Okay, so our endpoint at 2 is actually, actually at 8. So I probably didn't draw the graph that proportionally, but it goes up to 8. So we're at 2, 8 here. Okay, so what is my range of this graph? So we're going to label that f of x. Now obviously you're not going to cluster everything together like I have, but try to draw the graph in a way where you have space. So our range is from, and I might do this in the highlighter, range is from, for a range of y values, is from -1 to 8. So you're going to go range -1 to 8 inclusive. Okay, so it's really important that you get the right range. So -1 to 8 inclusive. Again, don't automatically assume it's the endpoint. Don't go, oh, the range is 0 to 8. That's not correct. You have to look at the graph for what it is, especially for quadratic. Even if you cut off at these two endpoints, you have to look at where the turning point is, because the turning point could affect what the range is. Now, we can do another one. We'll do D. So what D is telling us is we want to draw the graph of the quadratic, and there's no restriction on the domain. Okay, so we're drawing the full graph, except this graph we need to do some work on it, because it's, you need to find a turning point, you need to find the x-intercepts, etc. Okay, so for that graph, let's do some work on it. To get the turning point, to get the turning point, you need to use the scaffold. So if I go, if I go here, if I go x minus 1 squared, because I halve that, and I go -1, because 1 squared is 1, and then plus 3, I should get the value of my turning point. So -1 plus 2. So turning point is at 1, 2. And upright parabola. Okay, we're not going to get any x-intercepts, so it's good that we didn't actually attempt to get x-intercepts, because we're not going to get any. F of x, x, 1, 2. So 1, 2 somewhere over here. Our y-intercepts at 6, or f of x-intercepts at 6. So you're just going to do it like this. Okay, so that's 1, 2. That's 6. And our range would be from here, so it's starting here, to go to infinity, so it goes up there. So we're going to go 2 to infinity, like that, okay, including 2. So a lot of these graphs are very similar. For E and F, they're similar graphs, except you've got to be wary. Can you see the curve brackets here? What that means is that the endpoints are going to be not closed circles like this way, these, but they're going to be open circles, and you need to find what the endpoints actually are. Okay, so you have to find x-intercept, you have to find the y-intercept if any, and you have to find the endpoint. So there's a bit of work done there for these type of questions. For C, just briefly, for part C, that's just a 1 on X graph. You're not wanting the full 1 on X graph, so you're wanting the 1 on X graph from 0 to 3. So it's going to look, for part C, I'll just do this very quickly. We know that we've got a y, or x asymptote, x equals 0. We know we want the positive side, but we want it from 0 to 3. So we want it from 0 to 3. So we need to sub in f of 3. You should get 1 on 1/3. So it's 3 and a third. 3 and a third. Okay, so 3 and a third. So maybe a bit further down, but the endpoint here is 3 and a third. And what's my range? My range is from a third, and it goes up to infinity because that goes forever up there. Okay, so the range for this graph is a third to infinity. Okay, a third to infinity, like that. Okay, so I went through a few of these graphs. Hopefully you're able to have the confidence to actually draw some of them. Okay, now you are expected to know how to draw quarter-x. I mean, I know it's in chapter 3, but you know, this chapter is testing you on all the graphs we've learned so far. So chapter 3, chapter 4, so all the hyperbolas, truncuses, circles even, you need to know, and root graphs, you need to know how to draw and what the transformations are. Hopefully this helps.